Welcome to Homework Lib.
So we can use the energy for this if we want to. And we know that when all the energy is in the inductor, we'll have the maximum current, and when all the energy is in the capacitor, we'll have the maximum charge. So for the inductor, the energy should be equal to half of L times I squared. So that's part A that we're doing, which is equal to half Q squared over C in terms of capacitor. So from the first half of the energy equation, we can use the given numbers. So we have 85 millihenry for L. So that's 85 times 10 to the power negative 3 Henry times the current, which is 0.85, 0.85 times 10 to the power negative 3 ampere. Then there's a square, and that should be equal to half of Q squared over C. Then on the next step, we can actually calculate this energy, which is 0.307 nanojoules, or 10 to the power negative 9 joules. And this is equal to half of Q squared over C. Now from here, if we solve for Q, we already know the capacitance, which is 3.2 microfarad. So if we solve for Q from there, we should get Q as 44.3 nanocoulomb. Now in part B, we have to find out the magnitude of the charge on the capacitor at the instant when current in the inductor has a magnitude of 0.5 milliamps. So we can use the energy again, or we can use the formula for charge as a function of time. So the total energy should be equal to half of Li squared plus half of Q squared over C, because energy is now distributed among the capacitor and the inductor. So again, the total energy is given as 3.07 times 10 to the power negative 8 joules, which is equal to half of 85 times 10 to the power negative 3 Henry times the current, which is given as 0.5 times 10 to the power negative 3 ampere squared, plus half of Q squared, and we divide that by the capacitor, which is 3.2 times 10 to the power negative 6 coulomb. So from here, if we solve for it, we see that charge Q is equal to, so from here charge Q is equal to 3.58 times 10 to the power negative 7 coulomb, or in terms of nanocoulomb, it's 358 nanocoulomb. All right, thanks for watching. I'll see you next time.